Imagine you're aboard a spacecraft hurtling through the void of space. For years you've been traveling, years of darkness, years of cold, years of isolation. And then, finally, you see it. A small, pale world emerging from the black. Pluto. It doesn't look like much. A distant, icy sphere, barely larger than Earth's moon. Insignificant, harmless. But as you approach, your instruments begin to malfunction. Your communications start to fail. And then you realize something terrifying. You're not approaching a planet. You're approaching a graveyard. Pluto isn't just dangerous. It's a one-way ticket to oblivion. And in this video, you're going to understand why every mission to Pluto is a suicide mission. Why the few spacecraft we've sent there barely survived. And why, if humanity is smart, we'll never go back. Let's start with what Pluto actually is, because most people don't understand the scale of what we're dealing with. Pluto is small, incredibly small. It's only 2,377 kilometers in diameter. You could fit it inside the United States. It's smaller than Earth's moon. It's smaller than several other moons in our solar system, but size isn't what makes Pluto terrifying. Its location. Pluto orbits in the Kuiper Belt, a region of space beyond Neptune filled with thousands of icy bodies, comets, and debris. It's the edge of our solar system, the frontier, a place where the sun's gravity barely reaches, and it's cold, incomprehensibly cold. The average temperature on Pluto is minus 223 degrees Celsius. That's minus 370 degrees Fahrenheit. That's colder than the coldest place on Earth by a factor of 3. That's colder than anywhere humans have ever been. At that temperature, things we consider gases become liquids. Nitrogen becomes liquid. Methane becomes liquid. Carbon monoxide becomes liquid. Pluto's surface is covered in frozen nitrogen, methane ice, and water ice. But here's what makes it truly horrifying. Pluto's atmosphere is collapsing. Yes, Pluto has an atmosphere, a thin one, composed primarily of nitrogen with traces of methane and carbon monoxide. But as Pluto moves farther from the Sun in its elliptical orbit, the temperature drops. And when the temperature drops, the atmosphere freezes. It literally falls to the surface as snow. Scientists estimate that Pluto's atmosphere will completely freeze out within the next few decades. When that happens, Pluto will become even more hostile, even more alien. But the atmosphere isn't the only problem. Pluto's surface is a nightmare of geological chaos. The New Horizons spacecraft, the only probe we've ever sent to Pluto, revealed a world far more complex than anyone expected. Pluto has mountains. Massive mountains made of water ice. These mountains are as tall as the Rocky Mountains on Earth, but they're made of ice. At Pluto's temperatures, water ice is as hard as steel. Harder, actually. These mountains don't erode. They don't change. They're permanent features of a frozen, dead world. But the mountains aren't the scariest part. Pluto has cryovolcanoes. Cryovolcanoes are volcanoes that erupt not with lava, but with liquid water, ice, and other frozen materials. On Pluto, these eruptions would be catastrophic. Imagine a volcano erupting with liquid nitrogen and methane. Imagine the explosion, the chaos, the destruction. We don't fully understand how active Pluto's cryovolcanoes are, but we know they exist, and we know they're dangerous. And then there's Charon, Pluto's moon. Charon is massive, so massive that Pluto and Charon orbit around a common center of gravity. They're almost a binary system. Two worlds locked in a gravitational dance. Charon is half the size of Pluto, and it's covered in cracks. Deep, massive cracks that suggest the moon has been geologically active, that it's still changing, still shifting. If you landed on Charon, you'd be standing on a world that's literally tearing itself apart. But here's what really makes Pluto a death trap. The distance. Pluto is 5.9 billion kilometers from the Sun. That's 39 times farther from the Sun than Earth. Light from the Sun takes 5 hours to reach Pluto. If you were on Pluto and something went wrong, you couldn't call for help. By the time your distress signal reached Earth, you'd be dead. By the time help could possibly arrive, you'd have been dead for years. Pluto is beyond rescue, beyond help, beyond hope, and the journey there is a nightmare in itself. The New Horizons spacecraft took 9.5 years to reach Pluto, 9.5 years of traveling through the void. 9.5 years of isolation, and that was with a spacecraft traveling at 50,000 kilometers per hour. A human spacecraft would take even longer, decades possibly. And during that entire journey, the crew would be exposed to cosmic radiation. The farther you get from the sun, the less protection you have from radiation. By the time you reached Pluto, you'd have accumulated a radiation dose that would significantly increase your cancer risk. Your immune system would be compromised. Your DNA would be damaged. And you'd still have to survive on Pluto. Let's talk about what it would be like to actually land on Pluto. First, there's the landing itself. Pluto's gravity is incredibly weak. Pluto's gravity is only 0.063 times Earth's gravity. That means if you weigh 100 pounds on Earth, you'd weigh 6.3 pounds on Pluto. You could jump 30 meters into the air. You could throw a rock and watch it drift slowly upward. But this creates a problem. Landing is difficult. Takeoff is difficult. Any mistake, any miscalculation, and your spacecraft could drift away. You could find yourself stranded, unable to escape Pluto's weak gravity. And even if you managed to land safely, the cold would be your constant enemy. Minus 223 degrees Celsius. Your spacesuit would need to be incredibly well insulated, but no insulation is perfect. Heat would slowly leak away. Your suit's heating systems would have to work constantly, and if they failed, you'd freeze to death in minutes. But the cold isn't the only threat. The surface itself is hostile. Pluto's surface is covered in nitrogen ice, methane ice, water ice. These ices are slippery, treacherous. You could slip and fall. And in Pluto's low gravity, a fall could send you drifting away from your landing site. You could find yourself unable to return, stranded on an alien world. And the darkness. Pluto is so far from the sun that the sun appears as just another star in the sky. It provides almost no light, almost no heat. You'd be working in near total darkness, relying entirely on your suit's lights. And if those lights failed, you'd be blind, helpless. But let's assume you survived the landing. Let's assume you managed to explore Pluto's surface. What would you find? You'd find a world that's fundamentally alien, a world that operates by rules we barely understand. You'd find cryovolcanoes that could erupt at any moment. You'd find mountains of ice that could collapse. You'd find cracks in the surface that could open up beneath your feet. You'd find a world that's actively hostile to human life. And you'd find something else, something that haunts every scientist who studies Pluto. Evidence of a complex, dynamic world. Pluto isn't dead, it's alive, in its own way. The New Horizons data suggests that Pluto has been geologically active recently. Within the last billion years. That means Pluto is still changing, still evolving, still dangerous. We don't know what Pluto will do next. We don't know if another cryovolcanic eruption is imminent. We don't know if the surface will shift, if the mountains will collapse, if the cracks will widen. Pluto is unpredictable, and unpredictability is deadly. Now let's talk about the radiation exposure. You might think that being so far from the sun means less radiation, but that's not entirely true. While solar radiation decreases with distance, cosmic radiation becomes more of a threat. Cosmic rays from distant stars and supernovae bombard Pluto constantly. Without Earth's magnetic field and thick atmosphere to protect you, you're exposed to a constant barrage of high-energy particles. These particles can damage your DNA. They can cause cancer. They can cause neurological damage. An astronaut on Pluto would accumulate a radiation dose that would be lethal over time, and there's no way to shield yourself completely. Even inside a habitat, radiation would penetrate. You'd be slowly poisoned by invisible particles, and you wouldn't even know it was happening until it was too late. Let's also talk about the psychological toll. Imagine being on Pluto. Imagine the isolation. You're 5.9 billion kilometers from Earth. The nearest human is months away. The sun is just a bright star in the sky. The darkness is absolute. The cold is unrelenting. You're surrounded by a hostile alien landscape, and you know that if something goes wrong, you're dead. There's no rescue. There's no escape. The psychological pressure would be immense. Studies of astronauts in isolation have shown that prolonged isolation can cause depression, anxiety, and even psychosis. On Pluto, that isolation would be absolute. You'd be the only human on an entire world, the only warmth in a frozen hell, the only light in an endless darkness, and that would break you. Now let's talk about why we should never go back. Some people argue that we should send more missions to Pluto, that we should establish a research station, that we should explore further. But they're not thinking clearly. Pluto is too far, too cold, too hostile, too dangerous. The cost of reaching Pluto is astronomical. Literally, a single mission would cost tens of billions of dollars. And for what? To study a dead world? To gather data that could be collected by robotic probes? It's not worth it. The risk is too great. The reward is too small. And there's another reason we should avoid Pluto. Pluto is a warning. It's a warning about the limits of human exploration, about the places we simply cannot go. There are worlds in our solar system that are beyond our reach, beyond our capability, beyond our survival. Pluto is one of them. We can send robots, we can send probes, we can gather data from a distance, but we cannot, and should not, send humans. Because humans who go to Pluto don't come back. Not alive, anyway. The journey is too long, the environment is too hostile, the isolation is too complete. Pluto represents a hard boundary, a place we can study but never truly inhabit. A constant reminder that the universe is vast, cold and indifferent to human life. Think about the Fermi paradox for a moment. The Fermi paradox asks, if the universe is so vast, why haven't we found any alien civilizations? One answer is the Great Filter, the idea that there's some barrier that prevents civilizations from spreading across the galaxy. Maybe that barrier is distance, maybe it's the sheer difficulty of space travel. Maybe it's the fact that the universe is simply too vast, too hostile, too deadly for any civilization to overcome. Pluto is a microcosm of that problem. It's a world that's so far away, so hostile, so deadly, that reaching it and returning alive is nearly impossible. And if we can't reach Pluto, how could we ever reach another star? How could we ever establish a galactic civilization? Pluto teaches us that the universe has limits, and those limits are far more restrictive than we'd like to believe. Here's the sobering reality. Pluto has been here for 4.5 billion years. It will be here long after humanity is gone. And during all that time, it has never stopped being cold, never stopped being hostile, never stopped being deadly. When you look up at the night sky, you don't see Pluto. It's too far away, too small, too dim, but it's there, waiting, frozen, silent. A world that will never know human footsteps, a world that will never be home, a world that will never be anything but a graveyard for those foolish enough to venture there. And maybe that's okay. Maybe some worlds are meant to remain unexplored. Maybe some frontiers are meant to stay beyond our reach. Maybe the universe is telling us something, that there are limits to human ambition, limits to human exploration, limits to human survival, and Pluto is the proof. I hope this gave you a new perspective on the edge of our solar system. The solar system is far more hostile than it appears, and Pluto is the proof. If you enjoyed this video, consider subscribing, and I'll see you next time.